Okay, today we're going to go through a few different examples of questions involving moments. Now remember that moments are turning forces, also referred to as torque, and we calculate them by multiplying the force by the perpendicular distance. Sometimes we will need to resolve the force to make sure it's perpendicular to the distance that we have. Let's have a look at this question. We've got a uniform beam, that means the centre of mass acts in the centre of 40 kilograms and length 5 meters. I'm going to just annotate this drawing. So we've got a force of 40 G acting in the centre. We've got supports here, and we're told that the reaction force at D is twice the reaction force at C. So if I call the reaction force at C R, then the reaction force at D is 2R. And we've got a little man that's somewhere, and he has a mass of 80 kilograms, so he has a force of 80 G acting downwards. We want to find the distance from A to E, so where this guy is standing. We're going to resolve vertically. Because I've got these as an expression of each other, all of my forces going up, which is the reaction force at C and the reaction force at D, so R plus 2R, must equal all of my forces going down, which is 40G plus 80G. So therefore 3R equals 120G, so R equals 40G. Now I'm going to take moments, and I'm going to take moments somewhere. Let's take moments at A. I could take moments at C, I could take moments at D, I could take moments at the centre. I'm going to take them at A because I'm trying to find this distance, which I'll just call X for now. I'm trying to find this distance between A and the man. So if I take moments at A, I've already got that X involved. Sometimes you will take moments somewhere where you have unknown forces, because forces that act at the point you take moments do not create a moment because the distance is 0. So let's take moments at A. So my clockwise moments, ones that are going to create a clockwise turning force if we were pivoting around A. The force that's in the centre, so that is force, 40G, times the distance, which is 5 over 2, or 2.5, half the length, plus the force of the man times the distance, which I have just labelled as X. So let's just work out what this is. So that is 100G plus 80GX. Then we repeat that process, but for our anti-clockwise moments. So I've got my reaction force at C, which is 40G, times the distance, which is 1, plus my reaction force at D, which is 80G, times this distance, which is 4. So that's 40G plus 320G, so 360G. Now, because this is in equilibrium, then our clockwise moments must equal our anti-clockwise moments. 100G plus 80GX must equal 360G. Okay, now everything's being multiplied by G, so let's just cancel those out. Take away the 100, I'll get 80X equals 260, and therefore X equals 260 divided by 80, which is 3.25 meters. Now, because I took my moments at A, as I said, I found X, I found the distance that I wanted, the distance AE. Okay, so I can write therefore AE equals 3.25 meters. Okay, on some other questions, or if you took moments at a different place on this one, then just make sure that you're giving the answer that the question is asking at the end.